Hi everybody, this is part 2 for Module 1 for Math 026 for Hartford Community College, and we are going to look at rational exponents in this section. So a rational exponent is an exponent that is a fraction. So I know everybody fears fractions, but I promise you as an exponent they're not that bad. A rational exponent can be written as a radical expression using the following rules. So what they are saying here is that if you have a rational exponent, so here they're first dealing with if we had a to the 1 over n power, that would be equal to the base of your power. A is always your radicand. The denominator is always the index of the radicand or the radical. So n would go here, put there, kind of a bad n, let me erase it. Okay, and then the 1 or the numerator of the fraction is always the exponent of the base. So in this case, a 1, you don't have to really put it there. We see that more down here. We had a to the m divided by n power. So if we were to write that in radical form, a is your radicand again, n is your index, the denominator is always the index, and then m is the power of the base or the radicand. You can write it like this, or you can write it like this and put the power on the outside, and you'll kind of see both ways that we do it. So now we're going to look at and evaluate without a calculator and check our answer. We can check the answer with the calculator. Is 9 to the 1/2 power. So again, if I were to use my rules, I know I'm going to have this. I'm going to have a radical. 9 is my radicand, and 2, which we don't have to put in there, but we can, is my index. So the square root of 9 is 3. So 9 to the 1/2 power is equal to 3. Next we have 125 to the 1/3 power. So again, I'm going to put my radical there. My 125 goes on the inside. The 3 goes on the outside, and the 1 we can put it there, but again, you don't need it. And we know that the cubed root of 125 from previous videos is 5. And then our last one here, I'm going to write it up top here. We have 81 to the negative 1/4 power. Now, remember with negative exponents, you want to make them positive. So the first thing we're going to do is take the reciprocal there. So we're going to deal with 1 over 81 to the 1/4 power. And that gets rid of our negative exponent. Now we are going to put it in radical form. So we'll have 1 over the 4th root of 81. And I know that the 4th root of 81 is 3, so my answer would be 1/3 for that one. All right, next we're going to look at 25 to the 3/2 power. So again, when I put it into radical form, we'll have our radical, we have our 25. Your denominator is always your index. And then the 3, the numerator, is our power. And when you have a number there, I'm typically going to put the power on the outside. And you'll see why, because we can easily take the square root of 25 and then raise it to the 3rd power. I could do it the other way. I could do 25 to the 3rd power and then take the square root, but it's a much bigger number. This way I don't really need a calculator to do it, because I can take the square root of 25, which I know is 5, and then raise it to the 3rd power. And I know 5 to the 3rd power is 125. Next, we have negative 64 to the 2/3 power. And again, the exponent's not negative here, so we don't have to do a flip. It's just the base is negative. So I'll take my radical, I'll put my negative 64 underneath. My index is going to be a 3, because that's the denominator. And then we're going to raise it to the 2nd power. So the cubed root of negative 64 is, the cubed root of 64 is 4, so it's going to be a negative 4. But then we do have to square it, and if we square negative 4, we end up with 16. And then our last one here, we do have a negative exponent. So we are going to flip it. So we're going to make it 1 over negative 32 to the 4/5 power. And then we're going to put it in radical form. So it would be negative 32 is my radicand, 5 is my index, and then we'll raise it to the 4th power. I do know that the 5th root of negative 32 is negative 2, and we talked about that in previous videos. And I raise it to the 4th power, and it's going to be negative 2 times negative 2 times negative 2 times negative 2 is going to give me 1 over 16 for my final answer there. All right, so now we are going to approximate to the nearest thousand using a calculator. So when we do this, we're going to type it. I'm going to type it into my graphing calculator. Again, I will also post a video to go with this to kind of help you putting in those powers. And it's going to be to the 5/7 power. So I put it into my calculator. I did 1,000. I did the caret button on the graphing calculator, and I did my 5/7. And it came up with 138.9495,494. But they want us to round to the nearest thousandths, which is our 3rd decimal place. So when I look to the number next door, it's a 5, which means I actually have to round up to that hundredths. So my answer is going to be 138.95, because that 9 needs to become a 10, so I have to carry the 1 up there, so it becomes a 5. 950, or just 95. All right, next we have 135.6 raised to the negative 2/3 power. And when I do that, I come up with an answer. I'll put it in a different color. 0.037887898. And we're going to round to the thousandths. So there's my 7. And I look, it's an 8. So it's going to be 0.038 because we have to round up. All right, and my last one is negative 17/39 raised to the 1/5 power. So negative 17/39 raised to the 1/5 power. You should get an answer of negative 0.8469872307. And they want us to round again to the thousandths, so we have a 6. My number next door is a 9, so it will become negative 0.847 for my final answer there. All right, so now we are going to look at simplifying the expressions and writing our answer as a radical. And you may have asked before, like, why do we need exponents that are fractions? And, why do we need to know how to convert them into radicals? Well, sometimes it is helpful to use to be able to convert them and go back and forth between the two to simplify expressions. So one thing we haven't talked about, but we will later, is when you're multiplying radicals, you have to have the same index to multiply them. But if they're powers and you have the same radical or the same base, so we have x and x here, we can multiply those together and then turn it into a radical. So remember, when we multiply powers with the same base, you add your exponents. So right now, to get my answer here, I would do x, and then I would do 2/3 plus 1/5. Now, we can't add our fractions unless we have a common denominator. So I'm just going to move this down here. I'm going to say, well, 2/3 I can change into, let's see, we have 3 and 5. So we're going to make our denominator 15. So I multiply by 5 here. So I multiply by 5 here and I get a 10/15. And my 1/5, if I made it have a denominator of 15, multiply that by 3, so that by 3. So when I add those together, I'm going to end up with 13/15. So right now I have x to the 13/15 power, but they want me to write my answer as a radical. So my answer would be as a radical. Here's our radical. We have x. My denominator is your index, so 15 is my index, and my power would be 13. And because it's just a variable there, we're not going to do anything. We can put the 13 on the inside, or you can put it on the outside. So that's one way that going between the exponents and the radicals helped us out. Now for B, again, I can't divide radicals unless I have a common index, and this is the 6th root for the numerator and the square root for A, so it won't work. But if I rewrite them as powers, it would be A to the power first, so 5/6 power over A to the 1/2 power, because remember, if you don't see a power there, it's 1, and if you don't see an index, it's 2. Now, if you recall, with powers, when you're dividing them, you subtract your exponents. So I really need to do A, and then I need to do 5/6 minus 1/2. So again, I need to come up with a common denominator. My common denominator is going to be 6, so I'm going to do 5/6 minus, I'm going to turn that into a 6, so I'll times it by 3, so it would be 3/6, so it gives me 2/6, or I can simplify it down to 1/3. And so when I write my answer, I'm going to have A to the 1/3 power, or as a radical, it's going to be the cubed root of A. All right, now for C, I'm going to move to a clean slide so we can take a look at C. All right, so for C, we have some of our powers in radical form and some in power form or exponent form. Let's put them all in fraction form to start because we have different indexes. So we're going to start off, and I'm going to have C to the 1/4 power times C to the negative 1/2, all divided by C to the 2/3 power. All right, now let's simplify the top first. And again, if you multiply powers with the same base, you add those exponents together. So if we add them together, I am going to have 1/4 plus, and my common exponent, or my common denominator, excuse me, would be 4. So 1/2 would be the same as 2/4, but it's going to be negative because it's a negative 1/2. So I'm going to end up with a negative 1/4. So right now I have this. I have C to the negative 1/4 power fix that real quick. So C to the negative 1/4 power over C to the 2/3 power. Now, before I deal with that negative, what I am going to do is I'm going to simplify this down to one single power. When we divide powers, we subtract exponents. So now I'm going to do negative 1/4 minus 2/3. And we'll use a common denominator here of 12. So if I multiply 4 times 3, it will be that times 3. So negative 3 twelfths minus, this would be times 4, so 8 twelfths. All right, and negative 3 minus 8 is the same as plus that negative 8, so it gives me a negative 11 twelfths. So right now I have c to the negative 11 twelfths. And now that we're done and we've simplified it down to 1 power, we don't like negative exponents, so we do have to deal with that. So what we are going to do is I'm going to write the reciprocal, so I'm going to make it 1 over c to the 11 twelfths power. And then now we're going to write it as our radical. So it will be the 12th root of c to the 11th power. And that is it for part 2 of module 1. Again, take a minute, pause, study your notes, look it over, and then join us for part 3.